Hello and welcome to episode 100 of the HamCorp Training Manual. In this episode, we make our crafting systems more robust, optimizing patterns and throughput. We also finish off 4 of the 5 Beamlines, which is where we will stop for now. HamCorp would like to thank you for sticking with us all the way to episode 100. You are now authorized to enjoy a short break from work, starting now. That concludes your celebratory break. Please return to work. Before we continue, I just want to say I managed to figure out how to automate the component assembly line. So if you remember last time, I was saying that there's an issue with the program circuit 0 having way too many recipes, and I'm not able to add more input buses. And I had this idea to use an advanced stocking input bus, and that is exactly what I'm using. So you can click this button to toggle automatic item pulling. Right now it's toggled on, so it will pull everything it can from this ME chest. This ME chest currently has some stuff inside because I am running a craft to test it. The machine is off, which is why nothing's happening. But yeah, this can see the wrap of HV circuits, you can see the ender probe plate, and it has successfully placed the fluid into the input hatch. So everything's working as intended, but it's a little weird. You may notice that there's a third color here, and that's because there are 2 subnets involved. So first of all, there's the white subnet. This is exclusively to handle fluids. No items ever enter the white subnet. So this setup here for one of the other input buses, in this case program circuit 1, this is the same as what you've seen before. So this interface will be connected to the main net. Currently it's not because I want to test stuff. This will be connected to the main net. When you send items into it via a recipe, the items will go into the input bus, the fluid will go through the white subnet, and will be stored in the input hatch. For program circuit 0, it's different. So this is an advanced stocking input bus, of course, and it's pulling from an ME chest. This chest has a 16K ME storage cell. 16K was arbitrary, I just chose it because why not? And there's also a dual interface along with a green or lime cable. So this is a subnet, these 3 machines, or these 3 blocks, along with the fluid storage bus here. On the bottom, I have the actual mainnet interface that has the recipes, and on the white fluid handling subnet, there is also a dual interface. So what happens is the recipe pushes items into this green dual interface. I'm calling it green because it's on the green subnet or the lime subnet. It pushes items and fluids into this dual interface. Items go into the chest. Fluids get stored through this fluid storage bus into this interface, a fluid handler. So it just stores it over here. It basically just reroutes it from here into here. The reason I've done this instead of just directly making this part of the white network is because if I connect it directly to the white network, anytime I make a request on another input bus or another interface on the main net, it will try to put items into this interface. I'm not 100% sure that it will always put items into the bus. It might try to put items into the white net, and then it'll get stored in here and then pulled into this input bus. And that's a problem because everything gets clogged. So this extra layer of abstraction is my attempt to deal with that. And it seems to work. Also, check out how fast this is. So here is the base time, right? 1440 seconds for a stack of LV field gens. Just watch this. Done. Like, I don't even know what to say. That was so fast. That is crazy. Well, now I'm going to finish encoding the rest of the patterns. I don't think the other buses need this extra layer of bullshit, but the program circuit 01 kind of does. So back to my main objective for today. Finishing the rest of the beamlines. So I thought about just making the 4 remaining beamlines all at once, but I think it would be slightly more efficient for me to do them one at a time, because then I can encode the different engraving recipes onto each one as I build them, and then the next one will be just a little bit cheaper. I've already started gathering up some parts for my next Synchrotron, but I'm going to need another LINAC, another source chamber, another target chamber, and I will also have to figure out lanthanum hexaboride today. And if I'm going to do that, then I may as well upgrade this to lanthanum hexaboride. Also, I forgot, but the mega vacuum freezers can be wall shared while also sharing the inside, if you know what I mean. Like, it doesn't have to be air inside. So I could kind of, if you watch the Steam Age series, which is a little fourth wall breaking, but if you watch that, there was the Coke oven, and you could wall share by like putting them inside each other, which is super weird. But I'm going to do that again for these once I come back and refactor this. Also, to help with my crafting and to make it a little bit faster, I'm going to do two things. So first of all, I am going to go through all the recipes over here. It's going to take a long time. It's going to be painful. But I need to go through a lot of recipes and optimize them. And what I mean by that is, let me show you an example, right? So let's say I had a recipe that was 1 iridium ingot makes 1 iridium plate, which is sensible. And I put it into this machine. And now let me request 100. See what happens. See that it's just too fast. The machine is too fast. That the item export from the interface into the input bus is the bottleneck here. Like, this could have been done already, but it's still going because this is too small of a pattern. So that's one thing I want to address. In a lot of these recipes, I'm not using as many parallels as I could be, and I'm being limited by the applied energistics process of putting things into the input bus, which is weird that that's something I need to consider. I don't think I've ever had to deal with that before because my machines have never been this fast, which is cool. But the other thing I want to do is I want to make a large molecular assembler. I'm surprised there's no quest about this, but this is basically a multi-block molecular assembler. I'm not totally sure how this works, but I assume it's significantly faster, so I will be using this. It's not too hard, just some assemblers, tungsten steel. Actually, I could have done this a while ago. I'm going to do that, and then I'm going to start making more synchrotrons. Just a quick update, I have also refactored my mixing machine. I'm still running off of one mixer, which might be a mistake, but honestly, it's fine for now, and there haven't been any conflicts. It was mainly the LCR that was conflicting, but I've dealt with that. I have my usual white fluid subnet, and then, the same setup as usual. This is my main net. I haven't painted it, but it's my main net. And I noticed that actually some mixer recipes, or for some program circuits, the possible mixer recipes, none of them have a fluid component. So for example, program circuit 7, there are 2 mixer recipes. One is part of the monazite line, I think, or bastnasite line, or this might even be plat line. I don't know, but it's part of some line, so I'm not considering this. And besides that, there's just one recipe, and there's no fluid. So this doesn't need to be routed through the fluid handling subnet, so I just have it separate like this. And honestly, some of these kind of feel kind of wasteful because, like, circuit 20 has one recipe. That's it. I need to dedicate a whole interface and a whole input bus for one recipe because I do use this stuff. So it's kind of weird, but okay, whatever. That's done. Just got done upgrading all of these machines. So I've upgraded to electrum flux coils where I can, black plutonium where I can. Everything has been upgraded. All the patterns have been optimized as much as possible. And I've built the large molecular assembler. And it looks really cool. This vibrant quartz glass, the way it flickers or the way it has this little particle effect, I like it a lot. So the way this thing works is you need to connect the controller to your main net, and it needs to have a data orb inside. It needs an energy hatch, and the more energy you provide, the more parallels it gains. And I think at this point I have 16 parallels, if I've done my math correctly. And it should be working at 0.25 seconds processing time. So it's pretty fast. And now you may notice that there are a bunch of input buses as well. And actually this is where the patterns go. So I have here my pattern for a dual interface. It used to be in the old molecular assembler setup. And this goes in here. And now I can request dual interfaces again. And let me tell you, the pattern optimizations I did, I can really feel the difference in speed. It was quite a significant bottleneck. And I have a bunch of input buses here, but honestly, I think I might swap them out for a few super buses instead. I don't know, I don't think it really matters, so I'll just leave it as it is for now. The only problem with this is I have to physically come here to put in new patterns every time. I don't think there's a way to do it through the interface terminal because there's no interface. So yeah. But now I can free up this space for more crafting cores, and I think I'll make a few bigger ones. So these could be my small, random assorted tasks cores. And I think I'll make a few bigger cores here, and I'll also name the CPUs, because you can do that, and I haven't been doing that. Some of the Synchrotron crafts could really benefit from having larger CPUs because look at this one, 1.4 megabytes. The biggest one I have is half of that. I mean, it's fine. I could just do it in 2 requests, but I think it would be wiser for me to invest in bigger cores. So why not? I'm gonna rip this up, get some new cores, and let's see what kind of names I can come up with. I've finally made an extra circuit assembly line. This one is set to circuit assembler mode, which means I can finally get rid of all the circuit assemblers in my clean room. In circuit assembler mode, you can have input separation, and the way it works is basically like a regular multi-block. It's no longer an assembly line, not really. So the order in which you put items in doesn't matter, and in fact you can put them all in the same bus. Here is my program circuit 1 bus. So this has all of the storage component parts in it, so it just goes into the input bus, sends the fluid into the input hatch, and that's it. It just crafts like any other multi. Now I'm gonna try and just make the highest tier component I can for these crafting cores, which does mean I need tier 4 item processors. This is mostly okay. The only problem is the engraved quantum chips, because these come from exquisite yellow garnet, which I, so far, have mostly just been crushing up into dust because I assumed that they had no use. So there you go. But luckily there are meteor rituals for these, so I can replenish my supply once I run out. I do have a few. I have 76, so I can turn those into the quantum chips. Then I can make the tier 4 processors. Alright, I have made a few more crafting CPUs. These are all 4 megabyte CPUs, and I also made the 16 core coprocessing unit for more parallelization of item delivery. And what's more, as part of the 100th episode celebration, I have a few names. Some employees who just happened to be on voice chat with me while I was doing this have been commemorated. They have been uploaded to the cloud, and they will spend the rest of their existence crafting for me. If you would like to also name your CPUs, all you need to do is rename any of the blocks in your CPU using a Certus Quartz cutting knife, and I have a few motivational posters for them, just in case they need it. So now, in my crafting interface, there are new CPUs with names. Now I think I'm in a good spot to actually start crafting some stuff. So like I said before, I'm going to do it one synchrotron at a time. So I'll be back in a while. And if you were wondering if I was going to place this all by hand again, I do love to place block, but not that much. Yeah, my rule is kind of, I'm only going to do it the first time. So after the first time I place the multi-block, all future iterations are going to be with the projector, because I got things to do. I have quotas to meet, you know? Now, while all of this crafting is going, I actually looked a little bit closer, and making beamlines one at a time isn't going to make that much of a difference, because actually, a lot of these parts don't use circuits, so the wafer engraving is not really a bottleneck. So I could kind of just make it all at once. Anyway, in the meantime, I'm going to figure out lanthanum hexaboride, and by going to figure out, I mean I have figured it out. It is a few chemical steps. It's not too complicated. At this stage in the game, I think it's simple enough that it doesn't really deserve its own flowchart. But basically, I make phosgene, I make boric acid, and then from there, I make boron trioxide. That makes boron trichloride. That, along with lanthanum oxide, makes lanthanum hexaboride. And I get a tiny amount of boric acid back, but it's not a full refund. And also, when I lathe the flawless lanthanum hexaboride, I'm going to get lanthanum hexaboride dust. And the dust is kind of useless, except for to be turned into more rods, but kind of inefficiently. So I need to implosion compress it to make the gems, compress them again, or engrave them again, and then I can get more rods. So I'll just set that up somewhere here in the chemicals building. And by the way, I'm going to move these vats at some point. So I'm going to have kind of a shitty setup like over here for my lanthanum hexaboride. Or maybe I'll try to jam it in here, but the autoclave is pretty big, so I don't know if I'm going to be able to do that. Okay, a few final notes before I set up lanthanum hexaboride and before I finish my beamlines. I know I'm being really wishy-washy and going back and forth a lot, but I'm just realizing things as I do these things. So there's a lot of infrastructure that I've unlocked and haven't realized that I've unlocked. So one thing with the precise auto assembler, currently I have a ZPM energy hatch, But I totally forgot, or I guess I didn't know until a second ago, but this supports TechTech hatches, which means I can use 64 amp CPM hatches here. I could even use 64 amp UV hatches here. I'd have to upgrade the casings, but yeah. And on top of that, I think I can make the better casings, the better precise casings. That will increase the number of parallels I have from 32 to 64. So that's a pretty big difference. And after the beamline is done and stuff, and the circuits are cheaper and everything, I'll go back and refactor as many things around the base as I can. Because I really want to have super robust systems in place before moving on to UHV. Progress is going relatively smoothly. I've made a few more vacuum freezers. I've expanded to 5 so far, with space for 8, and I've calculated that I need a total of 14. It is a little overkill. I don't really need 14, but that's how many you need if all 5 beamlines are running at 100% uptime all the time. To keep up with the coolant for that, you do need 14 mega vacuum freezers. So I'm just going to make those because, I don't know, they kind of look nice. I can decorate it at some point, make it look even nicer. And I know I'm not wall sharing optimally, but I'm just doing it because it looks nice, and I kind of have a plan for what I want to do with this, but I'm not totally sure yet. Anyway, the second beamline is done. Everything is hooked up. I've tidied up the cables a little bit. I've started using wireless connectors, but I have come upon a small problem. It might balloon into a big problem, but I'm not sure yet. The different masks for the second beamline, they all need a mask tier 2 blank. I don't know why I didn't look into this, but this is not that easy to make. So first of all, it's a ZPM blast. That's fine. I need potassium hydroxide, which I've never used before, but it's fine. It's a pretty simple recipe. Lithium chloride I get from lepidolite, and processed mask substrate. This one is a bit annoying because it comes from mask substrate, and this comes from substrate precursor, which is actually fine, and silane nitrogen plasma mixture. And that might be an issue. So the substrate precursor is fine. It's just silane and glass panes. And silane, if you don't remember, we've seen before from trichlorosilane from making silicon poly-Si. So that's fine. That's just a bunch of recipes. I can teach that. That's okay. But the silane nitroplasma, this needs silane as well, but it needs nitrogen plasma, obviously. And nitrogen plasma, it's just annoying. Like, I need deuterium. I need molten beryllium. Oh, wait, never mind. It's just molten beryllium. I thought it was beryllium plasma. Okay, never mind. This is totally fine. I can do this as well. Besides that, things are coming along nicely. I am now the proud owner of 4 beamlines. I still need to build 1 more, but I am completely and utterly broke. I'm out of everything. I have 4,000 lead. I have 6,000 molybdenum. Down to 950 europium. Only 1,000 osmium left. I am not in a good place. But luckily, the 5th and final beamline is pretty low priority, because the recipes I can do in those, I don't even have access to them yet in the normal processing method. So, like, I don't need to build the last one yet. For the 4th beamline, I can only do 2 out of the 4 possible recipes, which is a bit sad because I was looking to get the crystal centroprocessing unit one done in the beamline instead of the engraver, because the engraver one is really slow. But the problem is the mask. The mask needs grade 6 water, at least. So I need to go back to the water line and expand it to grades 5 and 6, which is fine and going to be fun, but it means I need to struggle with the laser engraver for crystal circuits for a little bit longer. But the PPICs and NPICs are now in the LHC. I now have 10 mega vacuum freezers. I need 9 and 3/8 to keep up with all 4 of these, and I'm gonna need even more. Another, I think, 4 more vacuum freezers for when the 5th beamline is up and running, but that can wait for a bit. And I'm also struggling to get more europium because the europium ore comes from it comes from this meteor ritual, but you only get 32, so that's like not worth it. But this ritual takes the advanced crop synthesizer, which I made before. This needs a lot of americium, as well as neutronium, and the problem is I am just slightly short on the americium, so I have it fusing right now in the fusion reactor. I also need tritanium and UU matter. UU matter sucks. I didn't realize how much it sucks, but it sucks. I'm making some right now, but it's just going to take forever to build up. So yeah, so the beamlines are pretty much done at this point. And I know you want me to fly through the rings, so I'm gonna make you wait a little bit longer. Because I want to talk about what I want to do next, and that is upgrade my ore processing. The next upgrade to my ore processing, apart from just, making more machines, is to make the integrated ore factory. This does need UHV parts, which is a bit painful though, and UEV circuits. So this, I can't really do this yet. So this is kind of gonna have to wait a bit. And even though I would rather just make that and not parallelize anything here, I think I do need to parallelize a little bit. I'm not sure. I'm gonna see like how many machines I can just jam into this space without making any significant expansion and just roll with that. That should be fine. But yeah, I think the next steps will be either PCB factory or grade 6 water. And, just generally replenishing my supply of materials. Like the europium, this is painful to see 950 europium. Pretty recently I had like 40k europium and I've just gone through all of it. But yeah, I need to look more closely at the PCB factory and see how expensive it is to really make at the moment. And if it is extremely expensive, which I don't know if it is or not, but if it is, then I'll do grade 6 water first. Otherwise, I'll do PCB factory first and then grade 6 water. Now that that's out of the way, here's what you wanted. Was it worth it? Thank you for watching this episode of the HamCorp Training Manual. In the next episode, we will start building the PCB factory, allowing us to craft circuit boards for much, much cheaper. HamCorp would like to thank all employees for regularly watching the training manual. A well-trained employee is a profitable employee, and profitable employees are granted many benefits, such as a clean workspace, a familial atmosphere, snacks at a discount, and the right to continued existence. See you next time.